Okay, so welcome back.
Are there any other questions?
Seems not. Yeah, okay. So if you have question in any time, you can still write in the chat and we can try to answer directly.
Perfect.
Okay.
So we go on with the next topic. So connecting soil properties and measurements to the feature of interest. That is to the components of the soil model structure. To do this, we have to have a look at the observation and measurement standard, so the O&M in INSPIRE soil. So properties of soil spatial objects are modeled through associations with O&M observations. INSPIRE refers to ISO 19156, that is from 2011. Current standard is indeed from 2023 and is now called Observation, Measurement, and Samples. However, INSPIRE refers to the previous one, so to the O&M from 2011. And this is the standard we are going to have a look at. We will focus on the class that is OM observation. This because this class is used by INSPIRE to provide observations related to the special objects we have seen before. That is the soil site, the soil horizon, soil layer, and so on. So observation contains, it records information about the phenomenon time, the result time, the valid time, and also the quality of the result, and also possibility to provide a parameter as a named value. And it is linked, so the feature type observation is linked to the feature of interest, that is the real world object whose properties are under observation. In the case of INSPIRE, this, as I said before, the feature of interest can be a soil site, can be the horizon, the layers, so the special objects we have seen before. Then it is linked to the observed property, that is the individual property being observed on a feature of interest that is described through a specific metaclass, and linked also as well to a procedure that is the action performed on a feature of interest to measure a property. So a procedure that is on the right, in the upper right of the image we have on the right. And then clearly the observation is related to the unit of measure, so the magnitude of a measurement made on a feature using a specific procedure. And the result can be of any type, can be an integer, can be a text. Here are some example of the feature of interest. So soil horizon and radar. The procedure can be, for example, insaturated pest, and the property can be the pH, and yeah, the results in this case, for example, a number, so 7.5. This is the overview of the O&M, soil O&M from INSPIRE soil. And as you see, the OM observation feature from the O&M standard is linked to the feature of INSPIRE. Now we have to be very clear that the O&M observation is linked, as we have seen before, to the feature of interest. the feature of interest itself, so through the association named feature of interest. The feature of interest, so can be the soil site, the soil profile, can be the profile element, the soil derived object. INSPIRE, however, also provides for relations in the opposite way. So you can link to the feature of interest using the feature of interest association, but then you can link specific INSPIRE objects to their observations. So the soil site can have 0 to many soil site observations, which are feature types from O&M. So the association can be, because this is 0 to many, so it's optional, can be bidirectional. So the observation links to a feature of interest that can be spatial objects of INSPIRE model, but also the INSPIRE spatial objects can link to their O&M observation at the same time. When we have sensor-based observation, what do we do? The sensor observation service standard is used as one of the download services for INSPIRE data. There is a related technical guidelines. Sensor observation services is an OGC web service, and it is based on O&M that we have just seen, as an XML encoding, and as limited filtering capabilities. So, and it is also not that easy to implement. It's usually difficult to use. That is why, after the endorsement of the related good practice, INSPIRE sensor-based observation can only be provided according to OGC Sensor Things API standards, which is an API, so it's a lightweight API. It is also based on O&M and introduces the concepts of data stream as powerful query and filter options, and as GeoJSON or JSON, in this case, encoding. It is easier to use. While we are talking about this, because given the nature of the soil data of interest, mostly, even though not exclusively, based on sensor detections, the observation and measurements in the EJP SOIL proposal for INSPIRE soil we are talking about in these workshops are based on the OGC Sensor Things API, also named as STA, model. So that's why we are looking at this now. And this is the Sensor Things API data model that has been referred to. It is based on O&M. You see, we have the observation, we have the feature of interest, we have the observed property, and the sensor, that is the process procedure. Coffee break, we have just had one.
It's
so,
because we were thinking that maybe this part on observation and measurement is already quite a heavy one. So if somebody has already some question on this part, or because this is theoretical explanation, then in the implementation maybe it's clearer, but if somebody already has some questions now, it's free to make.
In any case, we will have also other slides when we will be talking about the implementation of the model. We have some slides explaining a little bit more this, but clearly, yes, I don't know how many have seen this data model before or have ever used this, data streams, observations? I don't know, indeed, there may be some questions on this. If so, please raise your hand and speak loud.
I don't think so, but
but in any case, you can
yeah.
use the chat, as we said before. Okay.
Yeah. I wanted just to clarify for some colleagues maybe that are of my formation, so pedologists, that the measurement can be done directly in field, so you can have an observation directly in field, or you can have an observation done in a laboratory. The case of sensor is when you have some sensor directly that is measuring automatically a property. So you have a sequence of data that enter the system, like, for example, measuring soil temperature or humidity or so on. So just to distinguish the different kind of observation we mentioned. Okay, so I give you the floor.
Yeah. Okay. Another piece we need to understand now to be able to get what EJP SOIL did is the GeoPackage, the GeoPackage encoding standard. This is a standard developed by OGC. It's more recent with respect to other standards. And it's an open format for geospatial information, and is open, platform independent, self-describing, so it's very compact format for transferring geospatial information. In practice, a GeoPackage file is a database container. So the file is a database with all the advantages this brings. A single file can store and handle large number of spatial features and related attributes in a relatively small size, and can store also tile matrix sets of imagery, can store raster maps, tile gridded coverage data, metadata, and schema constraints. And it is particularly suitable for use in the GIS desktop environment. The major plus of the GeoPackage encoding, the GeoPackage is well supported by common desktop, mobile, and WebGIS platforms, as well as by ETL tools. It is particularly efficient when connectivity and bandwidth are limited. And since the GeoPackage file is a database container, data can be accessed and updated in a native storage format directly. A single file can store multiple vector layers with different geometry type. Vector layers are specially indexed, and common operations such as loading, updating, and querying in GIS environment, for example, are fast. There is, in practice, no limit on the file size, hundreds of terabytes. It is possible to create special views and to filter using SQL queries. The GeoPackage encoding of INSPIRE datasets. The default encoding of INSPIRE is the GML. So it is an XML encoding document. So data as by default in INSPIRE has to be provided by using this GML document. Now it is possible to deliver INSPIRE dataset also using alternative encodings like the GeoJSON and the GeoPackage. And now, in particular, the good practice on the geopackage encoding of INSPIRE datasets, that is a specification. So it's a guideline, a specification available in the INSPIRE repository on GitHub, details how to create INSPIRE dataset in GeoPackage format. Datasets complying with the specification of this good practice are indeed INSPIRE compliant, so can be used to deliver INSPIRE data on soil in this case. The focus of the good practice is on producing geopackage models that are optimized for use in GIS environments, so geographical information system environments. And the good practice can be used on core INSPIRE models, on extended models, or even on specific use cases by community. This means that for the same INSPIRE theme, multiple models could become available over time. So the good practice on the geopackage encoding provides specifications, so what you have to do to produce INSPIRE compliant data using the geopackage encoding, but it is data theme agnostic. The theme-specific implementation of the good practice must be provided by the implementers, such as the member states and the public bodies, for example, the European Environment Agency, but also projects like, in this case, the EJP SOIL. These implementation examples must be documented on the INSPIRE GeoPackage repository. So you can see in the screenshot, this is the repository, and the repository contains an example folder. Again, these are the example listed by country and the data theme addressed, and there is one row for EJP SOIL and the related good practice for the geopackage encoding of soil datasets. From the good practice specification, we read that main benefits of the geopackage encoding of INSPIRE for soil are both for data providers and data users, because the data models are streamlined, so focus on key values, and this simplifies data harmonization. The encoding is based on the use of templates, of geopackage templates, database templates, and reduces number of schema and encoding errors. Also, the usability and the reusability of provided data is improved. And also, the geopackage file can handle large number of features in smaller file size compared to the GML. Let's say, usually GML size is double with respect to the GeoPackage one, or even more, thus facilitating the sharing and management of entire dataset sized medium to large. But also to data user, the GeoPackage it delivers some benefits, because the simplified data model aligns directly with specific use cases, so for community users. The geopackage encoded data can be directly used in a GIS tool with good performance, and geopackage data can be directly edited in a GIS tool, while this was not possible with the GML, complex GML features. So you had to operate using different ETL tools. Data consumption is considerably improved, not only because you can edit and update data, but also because you can create view, store styles, store metadata into the geopackage, and also loading data in the GIS environment or making queries on the file database is faster, since the vector layers are specially indexed. So how it works with the theme-specific implementation? To prove that what you propose is a theme-specific implementation of the good practice, for example, for soil, you must provide a description of the logical models, that is, starting from INSPIRE UML model, how you derived the GeoPackage model, in this case, the GeoPackage model, without information loss. Then you have to provide an empty GeoPackage template, so a template, so a database template. Then you have to provide description of the UML to GeoPackage transformation rules. So how did you transform UML to GeoPackage? And these rules must conform to some generic INSPIRE model transformation rules. Generic means that they are encoding agnostic, so they are common to those who want to use GeoJSON or GeoPackage or other encodings. So you have to conform to this model transformation rule, but also to GeoPackage specific transformation rules. In the end, you have also to provide an executable model for data transformation of GeoPackage data to GML default encoding. And this executable model can be an ETL workbench, for example, a Studio project or an FME workbench. Can be also a standalone program, or you can provide a service to transform on the fly. It's up to you. In all cases, this executable model must also be documented in a human-readable form. We will see how this has worked in the EJP SOIL case, because the EJP SOIL provides a theme-specific implementation for the soil data theme. So, theme-specific implementation must demonstrate technical compliance with INSPIRE by data transformation to default encoding and successful validation of the resulting dataset, so the GML, using the INSPIRE validator, because INSPIRE provides validating tools only for GML format. So if you want to demonstrate that your good practice GeoPackage is compliant with INSPIRE, you take your data in GeoPackage format, then transform into the GML format file, then take this GML format file and put it in the INSPIRE validator to get a report saying that you are compliant with INSPIRE. And this has been done for the EJP SOIL GeoPackage for soil. And once only validation, this is an important bit. So once you have a theme-specific implementation of the good practice, the data providers using the GeoPackage template that you provide together with the good practice document could avoid the conformity proofing process. This means that they do not have to transform to GML themselves, because they can refer to the relevant theme-specific implementation example validation. Clearly, they have to use the same GeoPackage structure that has been provided by the good practice, and provided that the good practice foresees quality checks on the GeoPackage contents, for example, the triggers. You will see this has been done also in the EJP SOIL. Hopefully this is clear. If not, please write questions in the chat. Because now we are driving into the GeoPackage model for the INSPIRE SOIL, so into the EJP SOIL proposal. So it's a theme-specific implementation. So what EJP SOIL has done is a theme-specific implementation of the good practice of the GeoPackage encoding of INSPIRE dataset for the soil data theme. So what they have done meets the need for an efficient exchange of soil data, and at the same time can be used to deliver INSPIRE-compliant soil data directly using the GeoPackage template that has been developed. The compliance with INSPIRE we have demonstrated in accordance with the provisions of the good practice on GeoPackage encoding. We are now going into some little details of how transformation of the INSPIRE soil conceptual model, so the UML, has been done towards GeoPackage database schema. So, as mandated by the good practice on GeoPackage specifications, we have, and by INSPIRE clearly, we have applied the generic INSPIRE model transformation rules, which are valid for all encodings. We have applied encoding-specific rules that are specified in a dedicated document for transforming UML to GeoPackage. And then we have developed transformation rule specifically for the soil data theme and in the scope of the EJP SOIL GeoPackage work. For example, just to give some details, not very details, but some details on the transformation rules we have applied. We have flattened hierarchical structures and complex data types. What does it mean? You have seen that, INSPIRE data models allow complex data types. That is, one specific attribute, let's take the most simple one, the INSPIRE identifier of a spatial object, can be made of many sub-attributes. So the INSPIRE ID attribute of the soil site is indeed made by three sub-elements that are the local ID, the namespace, and the version of the identifier. This is done in GML using complex structure nested into one another. Clearly, if you are operating on a database, you cannot nest structures. So we have to flatten hierarchical structures as well as complex data types. When multiplicity of the element was 0 or 1, the applied rule consisted in moving the child elements to the parent. That is, we had from the only INSPIRE ID attribute, for example, we derived three attributes: INSPIRE local ID, INSPIRE namespace, INSPIRE version. So this is an example of flattening. And this is flattening of a nested structure is one of the INSPIRE encoding agnostic rules. For multiplicity greater than 1, that is when in the INSPIRE model the attributes can be provided for the same spatial objects many times, this is not addressed by the INSPIRE flattening rules. In our case, we created tables for the data types. So to have multiple records for the same attributes. Another rule that has been applied is coming from the GeoPackage, UML to GeoPackage document I mentioned before, that is the GeoPackage properties rule. And also here, we refer to the cardinalities of the property. If a property of a feature type has a maximum cardinality of 1, it is mapped to a column in the related table. So the soil feature type, let's say, soil site feature type, the soil plot feature type, becomes a column, a table in the GeoPackage. And the attributes becomes a column in the table. And the column name is the same as the property in the INSPIRE feature. If a property has cardinality greater than 1, a suitable mapping needs to be found on a case-by-case basis. This is what is written in the GeoPackage property rule. And if a property represents values from code lists and enumerations, the type of the column is text. And the values from the code list and enumerations are encoding using the literal of the value. And also here, we have seen in the UML model of INSPIRE that associations can, with objects, apply. So the soil site is linked to many soil plots, for example. So in that case, the association, how did we transform the UML model of INSPIRE into the GeoPackage format, so into a database schema? We created a related attribute, so with the name of the association, in the destination table. And this attribute is a foreign key to the source table. So the soil plot as an attribute, so that is located on association with the soil site, contains a located on attributes, which is foreign key to the soil site table. In the case of N-to-M multiplicity, how did we operate? Many relationships have been represented using a relationship table, in which we have a primary key and 2 foreign key, 1 per associated table. So we have a table which associates the 2 tables, so the spatial corresponding to spatial objects related through association with an many-to-many multiplicity. Then we also applied, yes, I see a message from Maria. Yeah, that is saying not to worry if you do not understand everything. It is clear this workshop today is quite theoretical one. So for those who are new to these concepts, this is difficult to follow. But it is important to follow this workshop because in the other workshops, when we will touch with hands what is a GeoPackage template, what is an INSPIRE GeoPackage soil dataset, how this is used in QGIS, for example, how this is, you can input data into the GeoPackage, or how can you categorize the GeoPackage data. This will be clearer. In any case, we will have in few minutes the question and answer time.
Yeah, we have already maybe an interesting question, I think, from
You want to read? Because
Rob.
I cannot read now.
I read to you. It's from Rob Lockers, who says, so validation means first translating the simplified GeoPackage model back to the complex model in GML point, or does it also have a simplified GML schema?
No, we do not have simplified GML schemas.
So is the answer is a yes to the first question, I suppose.
Yes. How it works? We have the UML model, and we derive the GeoPackage model, that is a DB schema. So this is done from a theoretical point of view. So we create, we have the INSPIRE UML with the complex data type, nested attributes, and so on. Then from this, using the flattening, using all the rules we have seen before, we create an entity relationship schema, so a database schema. And we create the GeoPackage template that is an empty GeoPackage template that it is used as a kind of GML schema, no? As the same function of the GML schema. So we do not need to create the GML schema. When we want to validate, when I said that, but I will detail all this when I will talk about the validation of the EJP SOIL GeoPackage. In any case, I just anticipate a few concepts here. When I say that you have to demonstrate compliance, you have to transform back to GML, that GML will have the official INSPIRE schema, not a simplified one. So to demonstrate that your GeoPackage data is compliant to INSPIRE, you take your GeoPackage dataset as a source dataset. Then you create maybe a Hail project or FME. If you are used to FME, you have to use an ETL tool. And transform this GeoPackage into the complex GML of INSPIRE. Then you export the GML and you put into the INSPIRE validator and validate. And then you get back the report if the validation is successful or not. So we do not need any flattened GML. We don't need any flattened GML schema because we have the GeoPackage template that is our schema, the schema of our GeoPackage data. I hope I replied to your question.
I think so.
Okay. Other urgent question, Maria, or maybe I go on?
No, there are not. We can go on.
Okay, we can go on with soil-specific transformation rules example. So these soil-specific rules I am illustrating now are specific for soil, and in particular for the EJP SOIL proposal. So what are these soil-specific transformation? On the left, you see the original UML, the original INSPIRE UML with the soil profile class, and two feature types that are derived from it, the observed soil profile and the derived soil profile. And these two classes, observed and derived, have no attributes. You can see this, they are empty. Simplification we made in our GeoPackage schema for the soil profile that you can see on the right is that the observed soil profile and derived soil profile are merged in the only one table soil profile. And there is an attribute, a Boolean attribute called is_derived, can be true or false, that indicates whether the soil profile is observed or derived. So to streamline clearly the database, avoiding creating two tables, identical tables, also only the name would have been different, observed soil profile or derived soil profile, we create the only one soil profile table, adding an attribute of Boolean type, specifying if it is observed or derived. And this attribute is set to true when the profile is derived, clearly. And do you remember I said that to validate the content of the GeoPackage, sorry, to validate the content of the GeoPackage, triggers can be used. And in this case, we added a specific trigger, checking that derived soil profiles have null values for the location attribute. This because only the observed soil profile can be associated to the soil plot, because the soil plot is the physical location of the observation. Another specific transformation rule regards the profile element. On the left, as usual, the INSPIRE UML part that we had to transform into GeoPackage schema. So I hope it is clearer now what I said before. So going from the UML to specific DB schema, GeoPackage schema. So in INSPIRE, we have three feature types: the profile element feature type, which is an abstract one, then two table, one from the soil horizon and the other one from the soil layer. In our case, so in the GeoPackage schema, soil horizon and soil layer feature types have no corresponding tables in the model. All the soil layer attributes have been incorporated in the profile element table. So what we see in the INSPIRE feature type, the layer rock type, the layer genesis process, the environment, the process states, and so on, these attributes become parts of the profile element table. Because indeed, soil layer and soil horizon are profile elements. So these have been moved directly into the profile element. In the case of the soil horizon, since the soil horizon has complex data types, if you read, I hope it is visible. I don't know how much it is readable from the screenshot of the UML.
It's quite small. I don't think people can read, but
yeah,
okay.
Trust me that it is. This is the case. For example, the FAO horizon notation is a complex data type in INSPIRE, meaning that it has many sub properties that needs to be handled. So we applied the rules I've explained before for the complex data types. So the horizon attributes, the FAO horizon notation, the complex data type with multiplicity 1, and other horizon notation, a complex data type with multiplicity 0 to many, are represented as tables that are linked to the profile element through foreign keys. So, for example, the FAO horizon notation type, which characterizes the soil horizon, is a table you can see on the right. And you can see all the attributes you see in the FAO horizon notation type table. These are part of the INSPIRE complex data type. And this, as you can see, the key symbol here and the lens, this table, so the attributes, the specific record in one record of this table is linked to the corresponding horizon through the ID, so the foreign key, the ID profile element. Hopefully this is clear. But when we will open in the next workshop the GeoPackage in QGIS, it will be clear. I can see that Maria is replying in the chat, so please, Maria, do. But in few times, there will be also possibility for those who want to raise the hand and ask questions. So another soil-specific transformation rule is related to the soil body, and specifically to the soil body geometry. So since the same soil body description may refer to different geometry representation, for example, soil maps at different scales and different level of details, the geometry of the soil body, which in INSPIRE is in the related feature type as a GM multisurface, is handled in our data model, so the GeoPackage data model, in a dedicated table that clearly is linked to the parent table through a foreign key, so the ID of the specific soil body object. I don't know if there is any urgent question I have to reply, or
I don't see question. There is only a comment from Kathy.
Okay,
just
perfect.
underline that this has been a huge work to have this translation from UML scheme to GeoPackage, and that has been validated. So now we have the tool
Yes.
to use. Yeah.
This, you know, I don't know, maybe yes. Otherwise, I thought it was clear. This work has been already done by EJP SOIL team, so CREA and myself, and other people who also contributed to this in our think tank, let's say. And the GeoPackage template that has been derived can be directly used by data providers. So you can provide your INSPIRE data using the GeoPackage template directly. And I'm just explaining how all the work, all the huge work that I read, I have pop-ups with the questions.
Well, we have now a comment from Rob again. He says, so does the tool include the scripts to import, export GML? I don't think so, in the sense that we use
No, we have the
right?
studio project. We have.
Okay,
okay. But we will talk about this, don't worry.
After, yeah.
Yes,
okay.
Because there are so many things to say and to explain that clearly I understand that there are worries, no? How can I do this? How can I derive a GML and from the GeoPackage? There is a Health Studio project that is provided in the EJP SOIL GitHub repository, but I will explain this later, in which you can upload your data in GeoPackage format, and you can export the data in GML, just running the Health Studio project. But I will explain, okay?
Okay, I see a question from Rosario, but I think that we will answer after. So you can finalize.
We have question times, I guess, 2 slides.
Yeah, sure.
Okay, so we will come back. Just to complete this overview, we have to briefly come back to the Sensor Things API to model observation and measurements. So Sensor Things API provide a standard way to manage and retrieve observation and metadata from sensor systems, given the type of the nature of the soil data of interest that, as I said before, is mostly based on sensor detection. The transposition of the O&M model from the OGC Sensor Things API has been utilized for modeling observation and measurements. What does it mean? That we introduced the data stream concept. That's said in few words, but we will detail this. We will get into the details of this. Using the Sensor Things API does not affect compliance to INSPIRE, so it is INSPIRE compliant. And this because the related model, the Sensor Things API, contains all the necessary O&M information required by INSPIRE. So when you there is no information loss. You can always derive INSPIRE needed information. And there is, and also the EJP SOIL has also applied a specific transformation rule for the Sensor Things APIs, which is the rationale behind this transformation rule. A measuring instrument that is called thing in the Sensor Things API model may have multiple sensors. So the thing, the measuring instrument, may be composite of multiple sensors inside, no? And these sensors are sharing the same observed area, phenomenon, and result time. But each sensor has its own observed property, on process, and on data stream. That said, the output of the measuring instrument is a single file listing the data streams of all the sensors. So to be able to model the measuring instrument output, that is the single file with measurements from all the sensors, the EJP SOIL proposal adds to the model the concept of data stream collection. So we have both the data stream coming from the Sensor Things API and the data stream collection that has been added to model the single file that is the output from the measuring instrument. Okay. I will try to go slowly here, but clearly soon after this animation, there will be time for question and answer. And so you will have a possibility to ask. In this slide, you see on the left, the classic O&M model, and on the right, the Sensor Things model. You can see that there are, in all cases, observation that is linked to the feature of interest, so to what's observed. We have as well the classes for the phenomenon and the process, both in the O&M and the Sensor Things. And we have also the result, that in the Sensor Things contained in the observation feature, in the observation class, and in the O&M is a record and class metadata type. And so we have the observation, but in the Sensor Things API, we have, in addition, the data stream concept. The data stream and the thing, so the measuring instrument. So there is a perfect overlay regarding the phenomenon, the process, the feature of interest, and the observation result. But we have then the concepts of data stream and the thing. So data stream, we have a file information with many data streams, and the specific single data stream with results related to the specific observations. And so the data stream in our table links to the feature of interest, to the phenomenon, to the process, and to the observation. And also as a foreign key that links to the data stream collection. So the data stream connects the phenomenon, the process, the observation results, and the feature of interest, so the relations to these classes. And then we have the data stream collection that contains the generic properties that are, so the observed time, and as I said before, to the that are common to all data streams that belong to the data stream collection. So before going into the validation, maybe we can have the question now. I don't know.
I don't think that we have time because we are already 12:40. So maybe I think it's better if we finalize and at the end we have the time for questions.
Yes, because clearly it is, we went quite fast into this concept. So I understand that it is not easy to follow completely and to get completely. So INSPIRE validation. So this is related what we did to demonstrate that we are INSPIRE compliant with our GeoPackage data. The evidence of INSPIRE compliance has been provided in accordance with the requirements of the good practice on GeoPackage encoding, and all the needed artifacts that I list below are provided in the EJP SOIL GitHub repository. So you can see that, also a screenshot of the list of documents and folders available in the INSPIRE SOIL GeoPackage template folder under EJP SOIL. So what did we provide? First of all, a description of the UML to GeoPackage model transformation rules. So all the transformation rules that have been applied. So the mandatory INSPIRE model transformation rules, the UML to GeoPackage transformation rule, specific for the GeoPackage encoding and specific for SOIL. So this is there is a document that is the deliverable D64, indeed, where we describe all the rules that have been applied. Then we provide an empty GeoPackage template, both as a physical template, so a GeoPackage that is empty, or also via SQL scripts. So it can be reproduced just running the SQL. Then we provide an executable model for data transformation of GeoPackage dataset into INSPIRE GML dataset. This executable model is a Health Studio project. In the next workshops, I guess it is the third.
It is the third. Yeah.
We will also open Health Studio project and see what is an Health Studio project, how this can be used and reused. In your case, no, we have provided this project that takes in input a GeoPackage soil dataset, and as output derives a GML, an INSPIRE GML.
Sorry, Stefania, maybe not all people know about Hail.
Yes,
so maybe we can,
Exactly. It is. We will speak about this in the other workshops. That's why I didn't want to provide too many details here, also because we are almost done. But yes, Hail Studio is a software, data transformation software that takes as an input data in a specific structure, and as output provides the same data encoded according to a different structure and format. So we can have GeoPackage format in input and GML format in output, or GeoJSON, or whatever you want. You can go from GeoPackage to a different GeoPackage structure. This it is a tool that is free. For the community edition is free, but with the community edition, indeed, you can make a lot of things. For us, it was sufficient to use just the simple community edition. Then there is also a proprietary one, but so open source, no, not open source, sorry, free tool that you can use. Okay. And so you have to download Hail, install Hail if you want to run the project we have provided. You click on our project and execute the transformation. This is as regards Hail, but we will see in the next workshops. Then, so the GeoPackage source dataset was fully transformed into GML using this Hail Studio project. And this GML was successfully validated with the INSPIRE validator. So we validated using the specific test suite from the validator dedicated to the soil data team, and we fully passed the validation. This means, this is important because this is essential, proving that it is possible in our GeoPackage, all information that is mandated by INSPIRE is present. And it is always possible to go from GeoPackage we are providing, so dataset in GeoPackage structure for soil, is always possible to transform into equivalent GML dataset. And this is what is required by INSPIRE for demonstrating compliance of good practices. Just a sneak peek at the next workshop, we will see, for example, how this GeoPackage, the GeoPackage we have produced, displays in QGIS, how we have categorized it, which are the tables, and so on. So how you can
this is a
screenshot
an example. Yes,
yes, it's really an example.
Yeah.
It's an
because
example for Sicily.
Yeah, we have uploaded a data set that we own at CREA just to use the template and in practical terms. Yeah.
Yes. So, and this is also the GeoPackage data that has been then transformed to GML and validated. So we have this information we see here for Sicily, we have in GeoPackage format, and the same information we have in GML format because we have derived from this, and we can overlay in QGIS and demonstrate they are overlaying and so on and so forth. And clearly much easier to use in GeoPackage encoding than in QGIS, faster to upload. You can directly update, save, create views, create and all that we have said as plus for the GeoPackages. I guess this was the end. Yes.
Now, before the Q&A, we want to have a Mentimeter with you, so to have an idea also to target the following workshop that we will have based on also on your needs. So please enter. No, go back.
I want to share. I need to share. Okay.
Yeah. I can share mine. Yes.
Okay.
True.
Yes.
I can share mine. It is this one. Okay. So where is presenting this? Okay. So present. Yes, I think that people already entered. So please use enter to menti.com and put this code that you see on above the screen. So 32945833. I see only 6 people entering right now. So I will wait a little bit. Okay, so people is entering. $22, so we have 1/3 of the participants entering right now. So now we have near to the half of participants. So maybe I can go to the next. Yes.
Sorry for
Yes.
Italian. Sorry
Yeah,
for
yeah.
Italian. Maria,
Yes, yes, yes.
in quale devo andare io? Dove ci si segna? Per
You enter in, you put in the internet
Yeah.
www.menti.com.
Okay.
So you enter inside the Menti, and then you enter the code that you see above. Now I cannot see it no more.
Okay.
Yes, this code, and so you can enter into this Menti.
Okay, I understand. Okay, I try.
Did you see? Did you join?
Just a moment. Okay.
Because I cannot see you, so I don't know if you could enter. Okay, I suppose yes. So I will go to the next slide. I hope that everybody willing to participate is entered. So this is about the category you belong as a stakeholder. We are near to have all people participating to the first question that already answered. Okay. So we have even 2 students interested into private companies. Okay. Okay, I think that we can go to the next. So this is just to know which was your background participating to this workshop. So you will answer all the free, all the free statements with a strongly disagree or strongly agree scale. Okay. Okay, so I think that we can go to the next. Oh, more people is answering. Okay. Okay, this is for us just to know, you can write down your answer. So about the format you use to work, the standard that you use, both to store and to exchange information, not just to exchange, but also to store.
I can see also many PostgreSQL
Yes,
UTLs. So, but I don't remember if I mentioned this before. It is quite straightforward to go from GeoPackage structure to PostGIS structures, because they are databases, so you can almost reuse the same SQL scripts, just adjusting the dialect, let's say. But it's quite straightforward. So one can use the GeoPackage file when it needs to exchange data, and maybe for big operations and daily work can use the same structure in the
Postgres. Yeah.
Yes, Postgres or PostGIS. How do you want? Yeah, you need the spatial extension in this case, but yes.
Yeah, but I think that this image is quite interesting to know.
Yes.
Yeah.
Anyway.
Yeah. Okay, so the next, yeah, this is really important for me. So you may evaluate yourself as a soil scientist or informatic expert. So if you are in in which part of the screen you can put yourself. Okay, so I think that by my point of view, we have quite good situation also on knowledge about informatics, because we are near to be at the middle of the screen. So, okay, good.
Maybe now we can,
Yeah, it's quite finished. I wanted,
okay.
yeah, it's quite fitting. I want just to know
Ooh.
about the different parts of the presentation, which were the most difficult maybe to understand, or the most. So in which part maybe we could improve in the next workshop, so maybe we can have also some kind of recap of some parts if was not so clear. So So as expected, Stefania, I think that the sensor-based part maybe is the most difficult one.
But it is the most difficult.
Yeah, indeed.
Also for those who have to implement it.
Yeah.
But also in few minutes, it is not possible to make everything clear. But yeah.
Yeah. And also, I think that is one of the novelty of the last years, right? This sensor thing. Yeah.
So even less known than other encoding standard.
Okay, so yes, these are. Please feel free, put questions, doubts, suggestions, everything that you want. This is the last slide. So write down everything that you want. Because it's writing very large things, so it seems. Would one do a bring your own data mapping workshop?
Aha.
Non-EU countries. Well, if you follow the EU structure, I suppose yes. Right, Stefania. But you are not. But you are not surprised. Yeah, will the validator work for non-EU countries?
Oh yes, yes.
Yeah. PH from. Yeah. So you see also about the.
There is an online version of the validator, of the INSPIRE validator. But there is a limit on the file size. So you have to probably only validate sample data, which is 50 megabytes. But yes, it can be used, or it can be, it is free. In this case, the software which is behind the INSPIRE validator is free and can be used and reused and installed, deployed. Yeah.
Yeah, I see several questions about practical examples. Yeah, sure. The next workshop, as I mentioned at the second slide, will be practical usage of the tool. So I suppose that several doubts that for sure has raising up today will be also answered at the following workshops.
Yes, also the one that wrote clear examples of datasets and their INSPIRE compliant version. Yes, we will open both in the QGIS environment next time. Yeah, so follow the next workshop.
Yeah, sure. Yeah, and also, for example, this question about predict pH from mere spectroscopy. The question for me would be to them if they meant a map or, for example, a plot. So it would be different. But you need to have this, I mean, the predicting with mere spectroscopy is another process, but the property is pH. Yeah, but in any case, I will leave people to enter this slide. I see that there are only 8 people, and maybe we could also use this suggestion and question to make the last part of today's workshop to conversate on these questions.
Yeah. There is one open question in the chat. I don't remember from whom.
I don't see the chat, so.
No, it was. I will find it again. Doubts about soil profile tables. Rosario Napoli. I don't know.
Yes, sure. He had doubt about the use of the same table for observed and derived profiles, I suppose.
Yes, no, I didn't understand because the level of the structure, because I presume that derived was the new table to collect all the profiles, similar profiles belonging to one typological unit, but instead is not in this way, because you show that observed and derived are child of soil profile, so are below as an informative structure, and soil profile is the father of these two tables. So I don't understand. I understand that the derived in some way is not a measured observed profile, but where to put at this point the question is where to put in the structure the soil typological unit as a group of profile of the same type, because
I understand this. I think that people is not writing more things, so maybe we can also close the Menti and then answer.
Okay.
There is another one.
Sorry.
Yeah, this was just to understand if you think that this tool will enable or facilitate your work on. And this is the very last one. I forgot about this last slide. Okay, so people is willing to know in practice how to use the tool, I think.
Mm-hmm.
Yeah.
But clearly, we also went through the theory today, so it's really difficult to judge, no?
Yeah, sure. Yeah. So maybe we can present again this Menti with this question at the next workshop to see if it improved. Yeah.
But because it is clear that if you don't put your hands on it, it's just yes, you can have a feeling for it, yeah, already. I mean, above all, it is what we have done is also to have this compliance with INSPIRE, so the same data.
Yeah, but I feel comfortable that we have only one answering no, so it's good.
And this is good.
Yeah.
Yes. Okay, perfect. But yes, please follow next workshops because you will put your hands on the GeoPackage soil dataset and see what it is.
Yeah. Okay. So now I think that we have 26
above all for
answers.
interoperability, this is important.
Yeah, sure, exactly. During our EJPSOIL program, we have seen how many times people is struggling in exchanging data in a way that is understandable by everybody. So so a tool is really needed, but yeah. Okay, so I think that we can hand this.
Okay.
Okay, and I will share my screen. Okay. So we are a little bit over time because it's 12 minutes after 1, but yes, maybe we can answer to the question from Rosario, and if anyone
and then
else.
close, yes.
But
next time we are available for questions. Maybe next time we will start with a question and answer session.
Yeah, maybe we could also start.
Replied.
Yeah.
Okay, I don't know if you want to reply or Giovanni, or maybe I can. In the presentation, I mean, there are the soil bodies where you can have different derived soil profile for that area. I don't know if the question.
Yeah, I think that I understood the question from Rosario. The point is that in the same table, so the profile table, which could be both observed and derived, you put all the observation that you have for the profile, even if it is observed or derived. Then if it is derived, you will have, in our case, because we produce derived profiles, you will have, for example, mean values of the properties or standard deviation or the properties and so on. So this is the sense of having the same table for both observed or derived. I don't know if I answered correctly. Please correct me if I'm wrong.
Yes, but it's not only the type of data, is hierarchy. The hierarchy is different because derived could come from observed. So
maybe
inside the structure. Inside the structure, it's not correct to put at the same level. So if you can have this is a long discussion, so too long maybe for the end of
because it is but maybe we can take it in the next workshop.
But I suggest to differentiate to have different kind of session or maybe works before to go inside the informatic rules. I think it's better to clarify the concept of the soil structure, the meaning of the new soil structure of INSPIRE, that is not so to be all confident that we are talking about the same things.
So you are speaking about the UML structure, the theory behind.
Yes. And a final comment is, if I understand well, the validation for example, all the validation procedure and rules are concerned only to the informatic structure, not of the contents, of course.
You mean if the map, for example, of a pH in an or of
No, because
soil,
Maria, we generally use validation to validate with another meaning, not validation of informatic structure. That means that the informatic structure is right, but maybe the data inside are not validated.
Yeah. No, but there are triggers in the GeoPackage to
I think that also Andrea can answer to this.
But I would like just to very briefly tell Rosario.
That is a strong point.
Yeah,
because you can put a good informatic structure and validate from the informatic point of view, but maybe there is validation of data.
Yeah, there is also validation of data because we have this trigger that were
if you try to link I don't know the soil plot directly to a derived soil profile, you get an error. You are not able to do. The GeoPackage said, you are.
No, but for the data itself, for example, you can derive some feature of the elements that are maybe out of range, for example, for pH, or out of range for another characteristic.
Okay, so just to explain, Stefania, when you insert the data, this will be presented at the next workshop. There are triggers that don't allow you to insert wrong information. Okay, but then the question from Rosario was this validation that was performed now in the validator, was related only to the structure, not to the data itself.
No, also to the data. Regarding those checks that are foreseen by INSPIRE, because the INSPIRE validator checks data against INSPIRE requirements. For example, if you provided a Codulus value that is wrong, this is checked, and you. So it's clearly not everything, only what INSPIRE foresees as a requirement.
Okay, I think that this answers. Yeah.
Because we use the soil-specific conformance class that adds constraints and checks constraints and the other stuff. However, just to provide a hint to Rosario, this was not available in the presentation because the DB schema is quite huge, but a soil profile also contains, there is an additional table we didn't see that is based on observed soil profile that links the derived soil profile to the related observed soil profiles. So to the observed soil profiles to which it is related.
Okay.
So there is an external table, an additional table I didn't show because I could not show all the tables of the.
Maybe with as I suggested in the last Mentimeter, maybe with some practical example, we're going to clarify.
I think that the objective also of this Menti was to understand on how to construct properly the next workshop. So we have taken note, and I think that we will start with a kind of recap of the concepts that were not so clear today with practical examples.
Yeah. Thank you.
Yes. But clearly, as I said, INSPIRE, because here in the chat, I read Kati saying that INSPIRE does not check if the pH is valid, that this is true, because it's a number in INSPIRE. There is no specific requirements on this. So that must be additional constraint. This is true. But I guess in the GeoPackage we do, if I remember well. In any case.
In the trigger.
So we are more strict. We are clearly we are able to check more things on this because it's a database and you can This is a plus of the database structure. So I think we have to really close, Maria. It's 20 minutes after. So
yeah, so we close. We thanks everybody that participated to this workshop, and we hope that we will see you again in the next time in 1 week. Yeah.
okay. Bye everyone then. And you will find the recordings of the webinar. We will share the recordings of the webinar. Bye-bye.
Yeah.
Have a nice day. Bye.
Bye.